taking a radical and making it a rational exponent and vice versa, there's a rule that you need to understand. And it's exponent over index. So in number 1, our index is 3, and our exponent is 2. So when we change it to rational exponent form, we have x to the exponent, which is 2, divided by our index, which is 3. So our answer is x to the 2/3. And number 2, we have x to our exponent, which is 3, and our index, which is 5. And that's a rational exponent. When we look at number 3, we've got 2d to the 1/3. So we want to put it in radical form. If we see, it's not 2d to the 1/3. It's only d to the 1/3. So our 2 stays out, and our index, remember it's exponent over index. Our index is 3, so we're going to do the cubed root of d to the first power. Since it's understood that anything raised to the first power, you don't need to write the first power. So we can just leave it as 2 cubed root of d. And number 4, though, both the 3 and the x are being raised to the 1/2 power. So all we do is the square root of 3 times x. And again, it's understood that there's a 2 out here, so you don't have to write the 2 out in front. In number 5, we're dealing with properties of exponents. If you have a bunch of numbers and variables all being multiplied together, you can distribute this outside exponent. Now, you do need to remember if there's an addition or subtraction sign in between those values, you cannot distribute the exponent. But in this case, we don't have an addition or subtraction sign, so we're just going to distribute. So we have 2 to the 2nd power. And then if it's a power raised to a power, like in this one, you just multiply the exponents. So we have 4 times 2, which gives us a to the 8th. And then b to the, we have 3/10 times 2. And again, when you're multiplying fractions, you do the top, so the numerator, 3 times 2 is 6, over the denominator, which is 10. And 6/10 reduces down to 3/5. And because this is a rational exponent, you can put this in radical notation. So we have 2 squared, which is 4, a to the 8th, and we can actually do the 5th root of b cubed. Again, it's exponent over index. So 5 is our index and 3 is our exponent. For number 6, we multiply our numbers and our variables that are the same. So since 2 and 3 are both numbers, we can multiply 2 times 3, which gives us 6. Then we have our x's. So x to the 1/2 times x to the 1/4. And these are not powers raised to a power. These are just multiplying with the same base. So when we do this, we actually add our exponents. So it's 1/2 plus 1/4. And in order to add fractions, you can do this in your calculator. Just make sure your fractions are in parentheses, or we can get common denominators. So to make 2 into 4, we multiply both top and bottom by 2, and we get 2 over 4 plus 1/4, which gives us 3/4. So we get x to the 3/4, and then y is by itself, we get y to the 3/4 as well. Again, it's exponent over index, and they both have the same rational exponent. So our 6 comes out, and then we have our index, which is 4, the root sign, and then x and y, both of them are being cubed. So you could do x cubed times y cubed, but more simplified, we could do x and y in parentheses and raised to the 3rd power. And now we're going to look at simplifying radicals. So what we have to do is we're trying to find groups of 3 since our index is 3. So what we have to do is we have to take our number, which is 81, and we need to find all the factors of it. And I know that 9 times 9 gives me 81, so I'm going to reduce it down until I have all prime numbers. And both 3 times 3 give you 9. So I want groups of 3. And I have a group of 3 of my 3s. So the 3 can come out, and I'm left with this 3, which needs to stay in the radical. You only pull out your groups of 3. So then what you can do is you can take these exponents, and you can make them rational exponents. You get 5/3, b to the 3/3, and c to the 4/3. And what we do is we say, well, 3 goes into 5 how many times? 1 with 1 left over. So a to the first power, and then I have 2 a's left over. Then 3 goes into 3 how many times? Once, and nothing's left over. 3 goes into 4 once with 1 left over. And then you can pull out everything that's outside of a radical, so 3, a, b, and c. And everything that's in the radical just stays in the radical. So we have the cube root of 3, a squared, and then c. So your final answer is this right here. There is another way that you can do this. So if we take and we list out everything we have. So we have the third root. And we did break down 81, and we said that there were 4 3s. So I'm going to list those out. How many a's do I have? Well, I have 5. 1, 2, 3, 4, 5. Then how many b's do I have? I have 3. 1, 2, 3. How many c's? 4. 1, 2, 3, 4. And then you can just group 3s, because again, our index is 3, so I want groups of 3. So here's 1. I have another group here, another group here, and another group here. So everything that's grouped together can all come outside. So I have 3, A, B, C. And everything that's not circled needs to stay in the radical. So you get 3. A times A is A squared, and then your C. And that's how you reduce the radicals. And let's look at one more. We'll look at number 8. So again, you can do it either way, whichever way is easiest for you. We need to break down 45. What times what gives us 45? 9 and 5. Factors of 9, 3, and 3. Remember, if your index is not written outside of your radical, it's automatically a 2. So it's understood to be a 2. So we want groups of 2. Well, I have 2 3s, so my 3s can come out. But I'm going to have a 5 stay inside. 2 goes into 3 how many times? Once. So 1x comes out while I have 1 left over. 2 goes into 5 how many times? It goes into 5 2 times. And how many is left over? 1. So y to the first power. So then this is your final answer for number 8. And that's how you simplify radicals.